Test. Okay. Are we good now? No feedback? Okay. 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 Thanks everybody for coming. My name is Nightlord, and I'm going to be talking about grid computing with the Alchemy framework, which is built on the Microsoft .NET framework. Basically, probably the biggest question is here's a summary. What is grid computing? Grid computing is a form of distributed computing. If you're not familiar with the term of distributed computing, it means running threads on multiple processors on multiple systems. A few different modes is clustering, like supercomputers that universities have or whatever. That's a form of distributed computing. And then grid computing is the same theory, but instead of being in one location, they're scattered geographically. You know, they can be anywhere. It's connected over the internet as opposed to on a single network. .NET is the development platform in Microsoft Windows. They're up to the third version. XP and below runs 2.0, and then Vista, the new Vista, runs 3.0. And it's basically a collection of libraries and components that allow you to utilize the Microsoft built-in technologies that run natively on the operating system in your application, and it allows you to create programs a lot faster because the components are already coded for you. And then Alchemy is a framework built on .NET, on the communication libraries in .NET that allow you to utilize a grid infrastructure and utilize the object-oriented inheritability that you get from .NET and being able to piece together programs using functions that are already written for you. Okay, so grid computing is a computing model that uses multiple processors in separate geographical locations. So if I have an application that utilizes this grid, I can have a grid node at my house in Ohio. Somebody can have a grid node at their house in California, anywhere, and they all simultaneously act as one large computer. So you're unlimited as far as the amount of nodes that you can have or the amount of processors that you can have available to your application. It communicates with TCP/IP, and that's a little different than what a cluster does. Clusters use another protocol on top of TCP/IP to communicate with itself. The computers don't have to be similar. A lot of times with clusters, they have to be like the same type of hardware or running the same operating system or whatever. But with grids, it doesn't matter because it's only using the processor. It's not using the system itself. So as long as you have a handler that's handling the threads, it doesn't matter what version of OS you're running, what processor you have on it, none of that stuff. And it allows programmers to write more scalable applications. You can, if you are using an application that requires like a web app or something like that that a lot of people are hitting on, but you want to keep the response time good, you can use a grid infrastructure to basically outsource those packets or those threads and requests to the different nodes, and you can scale your application based on the amount of users that you have. So when you only have 10 users, your application is going to run just as fast as it does if it has 100 users because you have this vast grid of computers available for you. You can share nodes with other grids in most grid computing platforms. So I can have a grid, and then another guy can have a grid, and we can share our grids together. They could be separately, I could be running Alchemy, and then somebody could be running Globus, and then, but our two grid nodes, or the nodes between our grids can communicate with our own individual grid. And that may not make sense right now, but when I get into talking about the pieces of the grid and how it all works, it'll make a little bit more sense. You can utilize multiple processors as well as clusters in a grid. So if you have a supercomputer that has 500 and some processors, you can hook that up as an individual node within your grid, and then instead of it getting one thread, it gets one thread per processor. So it's getting 500 threads at a time when it's doing its request for threads. And also with individual PCs that have, or like servers that have 2, 4, 6, 8 processors, it also acts the same way. One thing that isn't built in to any grid platform currently, but I'm sure that they're going to work on it because dual core is kind of a newer technology. They haven't really gotten to the point where they can utilize that functionality and the low latency. So a dual core processor still is recognized as one single processor within your node. And recently, within the last 2 or 3 years, a new version of MPI, MPICH G2, was written in conjunction with 3 different universities that are on the MPI development team. And they created this version of MPI to be able to run over the grid. Now, the difference between MPI, and if you're not familiar with MPI, MPI stands for Message Passing Interface, and it allows a thread to communicate with another thread. So if you have a thread that you know this, because you can like submit multiple threads in different like routines. If you know that this thread has to complete before this one does, you can tell this thread to go ahead and tell the other thread, okay, I'm done, you can go ahead and go. So the difference between MPI on a grid and MPI on a cluster is the communication. Because you're only using TCP/IP with the grid, it's a different type of communication for MPI. It's a little less reliable. You know, you can lose packets all over the place on the internet. Usually when you're within your LAN, you have a lot more control over packet loss. So it doesn't rely so much on error checking and things like that. It knows when it gets the message that it's getting the full message. And with a grid, it's a little different. So they had to create a new version and able to make it so you know when you're getting the message, you're getting the full message, and it's not going to bomb out that thread or cause some kind of error. Here's some examples of what is currently being done with some grid computing platforms. These are Globus platforms, and Globus is like the granddaddy of all grid computing. I'll talk about that in a little bit. But these are the grid computing is more used in the scientific community or the academic community. These top 2, the one on the top left and the one in the middle, these are both earthquake simulations. They're done by UCLA and their extensive grid network, and to simulate earthquakes and the impact that it's going to have on a surrounding area. The one on the left shows shock waves, and then the one in the middle shows tectonic plate shifting, and then the tension, which are those big arcs of blue and red. It shows the tension going one way or the other. The one on the far right, that is a simulation of 2 black holes colliding and the gravity and things like that. The one on the bottom left is a blood flow through an artery. It's a simulation of that. So they can make a simulation of if you have a clot or a buildup of cholesterol, they can actually see, you know, how your blood is going to react and things like that based on whatever parameters they put in. And then the one on the bottom right is actually protein folding within a carbon nanotube. And that's kind of a newer project that they're working on. So here's some of the examples of what's currently being done in the research community. Limitations with grids. The usability of a grid or a cluster or any distributed computing platform is based on the ability to parallelize your code. What parallelizing means is no data dependency within that block of code. So you can consistently repeat that block of code, and it doesn't matter when it finishes because nothing relies on it, and it doesn't rely on anything else to complete. With MPI, the boundary between that can get a little bit faded because you can rely on another thread to do something, you know, to get that message passed. But generally, that's the point of distributed computing, is to be able to do a task over and over and over again very quickly. And then the other thing about grid computing, and most management, like grid management applications, have this built in as a built-in feature. If you're running a shared computer, like my home computer that I use is a node. This laptop that I'm using right now is a node on my grid, but I don't want it to be accepting threads while I'm using it. So it needs to know that you're using it and to stop accepting threads and to not process so it doesn't mess with your performance. Okay, how many people are in here are familiar with .NET? Just a couple, okay. I'll do a brief overview of what .NET is. .NET is Microsoft's development platform. It utilizes a ton of pre-written libraries and components that make up what they call the .NET framework. The entire Windows operating system is built upon the .NET framing, the .NET framework. So a button is already coded for you. So when you need to create a button in your application, that is the same code that the Windows operating system is using, unless you overload it or create a new function. And with .NET 3.0, you can tweak your component or your controls more than you could in the past. Like in 2.0 and before that, a button is a button or a list box is a list box, and that's what you get. Okay, with 3.0, you have a list box, but your list box doesn't have to act the way a list box does. You can change it any way you want, and it still inherits the functionality that a list box is, but you can tweak everything graphically, data binding wise, and things like that. It's like I said in here, it's predefined for GUI objects, data connection objects, data objects themselves, and any other piece of the Microsoft operating system. So every communication aspect, every function is essentially a .NET component, or there's a library for it, or whatever. And like I said earlier, it allows you to write applications very quickly, especially with the capability to be able to create your own components. You can create one thing and know that you're going to use that in a bunch of different places, and .NET gives you the tools to be able to make that its own little library or a DLL file, and then be able to utilize that in any application that you want. And you can do the same type of stuff in Linux, but the thing about .NET is it's included in every version of Windows. So you have a Windows box, you code your application using .NET 2.0, you can run that application on any machine that has .NET 2.0 on it because it's built into the operating system natively. And another thing about .NET is it doesn't compile into binary or a binary code anymore. It compiles down into it's called MSIL, which is Microsoft Intermediate Language, is what that stands for. And its original design was to make .NET be cross-platform or platform independent. Now, of course, Microsoft is not going to really endorse that all that much, but because it's not getting down to the binary level, and the MSIL or the CLR is available for anybody to do anything they want with, like the Mono project, it uses the CLR or the MSIL. When it compiles down, it just uses a different framework. Java is true platform independent. .NET was built on the principles of Java, but enhanced a little bit more. So it's a little less time-consuming to code. It's a little bit more compatible. You don't have to worry about the same type of errors. Obviously, you're going to get errors because it's Microsoft stuff. But here's a image of Visual Studio. This is the main IDE for .NET programming. Before the .NET 2.0 release and the 2005 release, you had to purchase Visual Studio. It was a pretty pricey application to develop in, but now they have the Express versions, so you can write Visual Basic, Visual C#, Visual C++, and Visual Web Developer, which is actually C# and Visual Basic, but it only outputs into ASP.NET files, so web apps. But those are free, and those will remain free, and they're just a lighter version of the full Visual Studio, so it's not as intense to run on your computer. I have, on this box, I have two versions. I have the VB version and the C# version, and this is written in C#. So this is the interface and how you get the .NET. Now the dot comes from, you see how like midway down the page it's got MySQL.data, .MySQL client, .MySQL connection. That's where the dot comes from. That's where they got that part of the name. Now the beauty about the .NET part is when you define an object, like down here you see this little drop-down box. Now I defined SB as a string builder, okay?